All right, today we're going to look at lesson 4.6, arithmetic sequences. All right, this is one of those lessons that you have not been taught this in the past. So I gave you a lot of information because I want to make sure that you have all the possible information that you could need. All right, so the essential question for today is how can you use an arithmetic sequence to describe a pattern? All right, well, you got to know what a sequence is. And a sequence, very simply put, is an ordered list of numbers. Okay, so I give you a list of numbers. It's called a sequence. The term is each number in the sequence. Okay, each number in the sequence. And you can see that we wrote down right here in this little chart, we have the list 5, 10, 15, 20, 25. And then way down the list, we have A sub n. Okay, so the term is noted by the position. So, for example, number 5 is in the first position of our list. Okay, 15 is in the third position. So, when we're talking about the term that I want you to find, I want you to find the number in the nth position. So, A sub n. If you notice this right here, you put it in your notes. I want you to be very careful because some of you on your test, when you had the point slope formula, y minus y sub 1, your ones were not in the sub position, okay? And it matters because if you put your number too high, you're making an exponent, all right? If you make your number the same size as A, you're saying A times that number. So you've got to be very careful when you're writing this. So A sub n, the n lets us know the position of the number that we're looking for. So I want you to take your highlighter and I want you to highlight the word position. That's the first thing, okay? Now, in order for our sequence to be arithmetic, it says the difference or the common difference. I want you to highlight common difference because that's what you're going to hear me say over and over again in this lesson. Okay? In order for it to be arithmetic, the difference between each pair of consecutive terms is the same. Now, let's talk about consecutive terms because this is also important. If we win 3 consecutive state football championships, what does that mean? Someone raise your hand. Explain to me what that means. Daniel.
3 consecutive means we won 3 in a row.
3 in a row. We didn't win one in 2010 and then win one in 2012 and then one in 2016. That's not consecutive. Consecutive is in a row. So 2010, 2011, 2012 as an example. Okay, so when we're talking about consecutive, we're talking about the terms in a row. Okay, so if the common difference, if the way we get from one number to the next is the same, then it's an arithmetic sequence. All right, so there's a lot of information for you. With that information, look at example 1, and you're going to have to actually add something to your notes because I added it earlier today. Example 1 says write the next 3 terms of the arithmetic sequence. So it's telling us it's arithmetic. But in order for us to write the next 3 terms, we have to know the common difference. So put this in your notes. Common difference. How do we find it? We simply take the second term minus the first term. The second term minus the first term. So let's look at letter A. The list they gave us is negative 12, 0, 12, and 24. So we want to find the common difference so that we can find the next 3 numbers. So we're supposed to take the second term. Which number is in the second position or is the second term? 0. So we're going to do 0 minus what is the first term?
Negative 12.
Negative 12. Now be very careful. It's a negative 12. So what jumps out at us right here?
Double negative.
The double negative, and they become positive. So 0 plus 12 is 12. So they're saying, or our common difference is 12. Now let's check it. Let's make sure that it works all the way across the numbers they've given us. Because if it doesn't, then they haven't actually given us an arithmetic sequence. All right, so let's try it. If I go from negative 12 to 0, and I add 12, what is negative 12 plus 12? 0. Good. All right, let's try it on the next one. 0 plus 12 gives me 12. And if I add 12 to 12, I get 24. So the pattern works all the way across. The common difference works every single time, so we know it is our common difference. Now, let's use it to find the next 3 numbers. What is 24 plus 12? 36. We add 12 to 36 and we get 48. And we add 12 to 48 and we get 60. Very good. So there are the next three numbers in our sequence. All right, so for letter B, what number is in the second position? What is the second term of this list?
3 and 3/4.
So we're doing 3 3/4 minus, what's the first term? 4. All right, now you got to be careful on your Casio. You got to be very careful. If everyone will take their Casio, you should either have a shift button or a second button. You need to hit that first, and then you need to hit your fraction button. Because by doing that, if you look above the fraction button, you can see on the calculator, that's where you're going to be able to punch in a mixed number. Okay, you're going to have 3 little squares instead of just 2. So we punch in the whole number of 3. We move the arrow, the cursor to the right. It goes to the numerator, which is 3. Hit the arrow down to put you down in the denominator, which is 4. And then you hit the arrow to the right, which finishes the mixed number for you. Now, I'm supposed to subtract 4. So when I do that, what do I get as my answer? Negative 1/4. So my common difference is supposed to be negative 1/4. Now, let's try it. If we do 4 minus 1/4. Now, clear your calculator, do 4 minus, and just hit the fraction button because it's just a simple fraction. 4 minus 1/4. Your calculator probably says 15/4, correct? So if we hit the shift button and we hit the S to D button, if you look above it, you can see that's a mixed number to a improper fraction or vice versa. So hit shift, hit the S to D button, and what number comes out? 3 3/4. Awesome. Hit minus, it'll keep your answer. And again, hit the fraction button and subtract your 1/4. It equals, you get 7/2. Hit shift, hit the S to D button, and what does that give you? 3.5, which is correct. All right, one more time. Hit minus, hit the fraction button, plug in the 1/4, and it equals 13/4. Hit shift, S to D, and what did it give you? 3 1/4. All right, so that's how you use your calculator to do these problems. Now, our common difference checks out, so let's find the next 3 numbers in the sequence. 3 1/4 minus 1/4 gives me what?
3.
Gives me 3. Minus 1/4 gives me, what's it give me?
3. 2 and 3/4.
2 3/4. And then if I do it one more time, I subtract 4, I get 5/2. Shift S to D gives me
2 and 1/2.
2 1/2. I'm sorry, it gives me 2 1/4. Okay? So here are the next 3 numbers in the sequence. How many of you got that right? Raise your hand. Okay, we got part of it? All right, good. So we found the common difference, second term minus the first term. We checked it out. We made sure it worked on all of our numbers, and then we used it to find the next 3 numbers. All right? Any questions? And it's not 1/4. I don't know. I must have punched something wrong on my calculator. It is 1.5. 2.5, sorry. 2.5 is the correct answer. Okay? Any questions? All right, now let's look at graphing a sequence. Here's what you need to know. Here's what you need to highlight. The position of the number is the x value, because so far I'm looking at a list and I know I can't graph points without an ordered pair. So how do I create the ordered pair? Well, how many numbers are in my list? 4. So I'm going to start each ordered pair with a 1, and then a 2, and then a 3, and then a 4, because my x values are the position of the number they give me. So what number was in the first position? 3. So my first y value is 3. So my ordered pair is 1 3. What number is in the second position? 6. So my second y value is 6, and that completes my second ordered pair. What number is in the third position? 9, and that completes my third ordered pair. And then what number is in the fourth position? So my fourth y value is 12, and that gives me 4 ordered pairs. Now, we should all know how to graph ordered pairs by now. Layla, talk me through graphing 1 3. Huh? I'm going to go right 1 and up 3, and I'm going to plot my point. Awesome. All right, how do I graph 2 6, Daniel?
2 6. Up 2. No. To the right 2.
Up to the right 2, and then up 6. Awesome. All right, Tristan, how do I do 3, 9?
To the right 3.
Good. To the right 3 and up 9. And then 4, 12. Jaden, how do I graph 4, 12? I'm going to go right 4 and up 12. And I'm going to have to go a little bit off of my graph. But what do you notice about this graph? What are those points doing?
Going up and
Okay, the points are going up. All right, so that's pretty simple. Here's what they're trying to teach you. They're trying to teach you, okay, how to graph a sequence, number 1. They're also wanting you to notice the points. Are the points going up? Are the points going down? Is my common difference increasing or is my common difference decreasing? All right, now let's look at example 3. Now that we know how they have or how to graph this, let's look at one that's already been graphed. All right, does the graph represent an arithmetic sequence? Well, first of all, let's identify our x values. Let's make sure that the ordered pairs that are represented on this graph are consecutive numbers. All right, so Travis, what are the x values of these points?
1, 2, 3.
So does that mean that these points represent consecutive numbers? Yes, because remember the x coordinate is the position of my number. Now, what are the y coordinates? What numbers, Chase, are in my list for this problem? 2, 4, 7, and 11. So the question is, does this represent an arithmetic sequence? Well, since they are consecutive numbers, what do we know about the common difference? The common difference has to be what? Look back at your definition. Look back at your definition of an arithmetic sequence. What does the definition of an arithmetic sequence tell us? Say it again, Malcolm. The consecutive terms. Read the definition to me.
Common difference between each pair of consecutive terms
Is the same. Did you hear what the definition says? Okay. It says the common difference of consecutive terms is the same. So we got to find the common difference and see if it's the same all the way across. How do we find the common difference? Subtract the second term minus the first term. So what is 4 minus 2? 2. So we got to check it out. 2 plus 2 is 4. But is 4 plus 2 equal to 7?
No.
No, it's not. So is this an arithmetic sequence?
No.
No. And why is it not an arithmetic sequence? What's
It's not consecutive.
okay? Our consecutive terms do or do not have the same common difference?
Not.
Do not. All right, so this is our explanation. No, the consecutive terms, because we know they're consecutive, don't have the same common difference. So that's how we know. We know they're consecutive because of the x values. It was 1, 2, 3, and 4. But when we find the common difference, it does not work all the way across. It doesn't work on every single number. So it is not an arithmetic sequence because the consecutive terms don't have the same common difference. That would be your explanation. Okay? And that is what we would box in. Are there any questions on this one? Awesome. All right, now this is where it gets fun. The equation of an arithmetic sequence. We are going to have to write equations for these different arithmetic sequences. All right, so that means we're going to have to learn this formula. So highlight it. All right, this is just like when I asked you to memorize y equals mx plus b or y minus y sub 1 equals m times x minus x sub 1. This is a formula that you need to memorize. It's the arithmetic sequence formula. So let's break it apart. First of all, we have the a sub n. Now remember, this is telling us what term we're looking for. The n tells us the term that we are looking for. The a sub 1. Now let's break this apart. If it's normally a sub n, and for this part it says a sub 1, what number are they looking for? If the n has become a 1, then which number do they want? They want the value of the first term. All right, so this is making sure you understand. If a is normally a sub n, but they have a sub 1, they're asking you for the value of the first term. Okay, what if this had said a sub 4? What term are they wanting you to look for? Fourth, okay? So a sub 1 every time, they want the value of the first term. Then you've got n. We've already talked about n. N is the position of the number. Is it in the 4th position? Then it's the 4th term. Is it in the 7th position? Then it's the 7th term. Okay? And then D, we've already talked about this as well, is the common difference. And you find it by doing the second term minus the first term. All right, now, let's look at example 4. It says write an equation for the nth term. So we're going to write an equation without knowing what term they want us to find of the arithmetic sequence. Then we're going to find a sub 25. So once we've written the equation, then they're asking us to find which term. If it says a sub 25, they're asking us to find which term? The 25th term. So rather than sit there and do the common difference 20 more times, they're going to have us use the formula to quickly find the 25th term. But we got to write the formula first. So here's how we do it. I've given you 3 steps. Highlight them. If you don't memorize these, you will be lost. So memorize them. Let's go over them carefully. First of all, we are going to plug in a sub 1 and d. So let's identify, first thing, let's identify what a sub 1 is, and let's find the d, or the common difference. Now, if a sub 1 represents the value of which term?
4.
A sub 1, the first term. Look at the list in this problem. What number is in the first position? What's the first term? 4. So a sub 1 equals 4. Now, how do we find the common difference? 5 minus 4. The second term, which is 5, minus the first term, which is 4. So what is 5 minus 4?
1.
Awesome. The common difference is 1. Now, we're supposed to plug these in. Well, what do we plug them into? We plug them into that formula that we just wrote down. So let's write down the formula. It's a sub n equals a sub 1 plus, don't forget that plus sign, n minus 1 times d. How do I know it's times? Because there is no sign between the parenthesis and the d. All right? We don't know a sub n, so we're just going to keep it a sub n. What is the value of a sub 1? 4. So we're plugging it in. We found the first term of this problem was 4, so we're going to put that in place of a sub 1. Now we bring down the plus n minus 1. That won't change. And what did we find the common difference was? 1. Okay? Now, step 2 says distribute. Well, what am I distributing? Somebody raise your hand and tell me, what am I distributing? Loza. Okay, I'm distributing the 1. So I got to be careful because I'm not used to the number I'm distributing being at the back of the parenthesis. I'm used to it being in the front, but that doesn't change the fact the 1 is sitting outside the parentheses waiting to be multiplied. So I'm going to bring down my a sub n. Going to bring down equals 4 plus, and I'm going to distribute. So Loza, when I distribute 1 times n, I get 1 n. You can put 1 in, you can put n, it doesn't matter. And then I'm supposed to distribute the 1 times the negative 1, which is negative 1. Now, final step, simplify. How do I simplify? I follow don't call me after midnight. I already did the D. I already distributed. What does the C stand for? Combine like terms. Do I have any, Luke, like terms that I can combine in this problem? What? Awesome. 4 and negative 1. So I'm going to bring down the n term first. I'll always bring it down first. And then what is 4 minus 1?
3.
What kind of 3?
Positive.
Positive 3. And I'm going to box this in. Because this is the equation for this particular arithmetic sequence. It is part of my answer. Now, once I have the equation for this problem, they want me to find a sub 25. So again, what term are they asking me to find? 25. So I'm replacing n with 25. I have a sub 25 equals. What am I putting in place of the big N in the problem?
1.
No, what is the n value?
25.
25. Does everyone see that? Listen, this is a sub n. Okay? I just replaced it with the 25th term. They could have asked me for the 12th term if they wanted to. If they put a 12 here, I'm plugging a 12 into the equation. But they want the 25th term. So if the formula says a sub n and I've put a value in place of n, then what value is going in place of n in my equation? 25. Good. So 25 plus 3. A sub 25 equals, what's 25 plus 3? 28. So the 25th term, if I sat there and I added 1, and added 1, and added 1, all the way to the 25th number, I would get 28. But who has time to do that? So that's why we write the formula and then we plug in the value. Now, just for sake of what if they had asked me to find the 10th term? If they had asked me to find the 10th term, then what number would have gone in place of n?
10.
And 10 plus 3 would have given me 13. Okay, good. So the more you see this, the more you're going to get it. Now, I want you to work letter B with your partner. All right? Follow the steps and work with your partner. All right, to write the equation for letter B, we got to start by identifying a sub 1. So what is the first term in this problem? 1. Awesome. All right, we're then supposed to find the common difference. So Layla, how did you guys find the common difference? 0 the second term minus 1, which was the first term, and you got what, Layla? 0 minus 1 is negative 1. Awesome. So I've identified my first term and I've identified my common difference. So I'm going to write down the formula. A sub n equals a sub 1 plus n minus 1 times d. So let's plug in what we know. We know the first term. We know a sub 1 is 1 plus n minus 1. Now this is why it's important to plug d in parentheses. If I don't, I'm going to think that that's minus 1. And that's going to throw everything off. So I like to plug things in parentheses, and this is a good reason why. All right? Caleb, what did you guys do next once you had plugged in your values? What did you distribute? All right, right here is where we have to do our distributing. So we bring down the a sub n equals 1 plus. And Caleb, what did you guys get when you distributed? Negative 1 times n is negative n. And you can put the negative 1. You can put 1 if you want. You don't have to. And then, of course, a negative 1 times a negative 1 is a positive 1. All right, Chase, how did you guys simplify? Good, the 1 plus 1. So a sub n equaled what? Negative n plus 2. All right, just by a show of hands, how many of you got the right equation? Okay, just by a raise of hands, who got the right equation? All right, now we have the equation, and again, they're asking us to find the 25th term. So a sub 25, we're replacing n with a 25, equals negative, what's going in place of n? What term are they asking us to find?
25.
The 25th plus 2. So that is negative 25 plus 2, and that equals what? Negative 23. So again, if I wanted to sit there and I wanted to subtract 1 over and over and over and over again until I got to the 25th term, I would get negative 23. But the equation helps me get there much quicker. All right? Any questions? Now, let's take that information and let's look at this word problem. All right? It says a carnival charges $2 for each game after you pay a $5 entry fee. So this problem is all about the number of games that you are playing at this carnival. So we know that in order to write a function, first of all, the key word here is function. When we see the word function, what form do they usually want our answer in? Yes, but even more than y equals mx plus b, what do they want instead of y? All right, they want f of x equals mx plus b. All right, so that's good information to write down just so we don't forget. Now, we're writing the equation again, and we just learned the steps to doing that. So we need to identify the first term, and we need to identify the common difference in order to write the function. So let's think about this for just a second. You go to play your very first game. How much money have you paid so far?
$9.
Okay, hold on. Let's raise our hand. Somebody raise your hand and tell me. All right, Avery.
So after paying for the first game, you paid $7.
All right, how did you pay $7?
You paid an entry fee plus to play.
Okay, you had to get into the carnival, right? So to get into the carnival, you paid $5. Then you went to play your first game and you paid $2. So by the time you've played your first game, you have paid $7. So 7 is your first term. Now, I move on to the next game. How many dollars do I pay to play the next game? Just 2, right? I already paid. The $5 is a one-time thing. So now, as I move from game to game, what is my common difference? The 2. Every time I go to a new game, I got to pay $2. All right? So, let's write down our formula. A sub n equals a sub 1 plus n minus 1 times our common difference. All right, let's plug in what we know. What is the first term? What is a sub 1? 7 plus n minus 1. And what is our common difference? 2. Awesome. Tristan, what do we do next? All right, what are we distributing this time? The 2 is being distributed. So when we distribute that, Tristan, we get what?
7 plus n minus -2.
All right, be careful. Did you distribute the 2 and the n first?
No.
Okay, the 2 is being distributed by everything in the parentheses. So it's 2 times n, which is 2n, and then 2 times -1, which is -2. So a sub n equals... Tristan, what do I bring down first? Nope. 2n, good. And then I simplify the what?
7.
Okay, which are? What is 7 minus 2? Positive or negative? Positive. Now, before you box that in, remember it said write a function. So instead of a sub n, we're going to put what in our final answer? All right, but we're not using an x in this problem. We're using a n. So it's going to be f of n is equal to 2n plus 5. So it's still that same idea. Why are we not doing f of x? Because there's not an x in this problem. They're using the variable n. So f of n is how we're going to write this one. Okay, any questions so far? Now, we got to go to step B, which says graph the function. And you know, how many points does Miss Johnson like when we're graphing things? 3. So we're going to create an X and a Y chart. All right, but we got to be careful. Okay, this is where it gets a little bit tricky. We've got our X. And actually, are we, we'll use X and Y for right now. But our function is f of n equals 2n plus 5. And then, of course, our Y value. But what does our X and our Y represent? Because this is important. This is where word problems get tricky because we don't know what each variable is representing. So if instead of X we used n like the problem does, what is the n representing? Because think about it. We've done games and we've done money. So which one is the n representing? The number of games or the amount of money we've spent? The games. So I would make myself a little note over here that says games. That's going to be important when we get to part 6. Or part C, sorry. All right, now Y. Instead of Y, we're actually, when we solve the function, we're actually solving for what? F of, aren't we using f of n? And what does f of n represent this time? If n is the games, then f of n is the money. All right, again, that'll be important here in just a second. Now, does it make any sense for me to use negative numbers if n represents games? Can we play a negative amount of games? No, and we're not playing 0 games either. So we're going to use for our x values 1, 2, and 3. Again, the position of the number. So we're going to plug 1. So f of n equals 2 times 1 plus 5. f of n equals 2 times 2 plus 5, and f of n equals 2 times 3 plus 5. All right, let's do the math real quick. What's 2 times 1? Plus 5. 7. What's 2 times 2? Plus 5. And what's 2 times 3? Plus 5. 11. So our 3 ordered pairs, when you play 1 game, you pay $7. When you play 2 games, you've paid $9. And when you've played 3 games, you've paid $11. All right, so let's graph them. We go right to 1 and up to 7. Right to 2 and up to 9. And then right to 3 and up to 11. No lines necessary. We're just going to plot the points. Okay, understanding the common difference. The amount of money I spend raises by $2 every single time. Now, look at part C. It says how many games, and what variable represents the games in our problem? The N. Can you play when you take $29 to the carnival? Now, what variable is represented by the money? F of n. Remember, we labeled our X and Y chart over here. Okay, the games is represented by the variable N. The money, the $29, is represented by the F of n, the Y. So we write down our formula, which we found in part A. What was our formula again? F of n equals 2n plus 5. And we are given $29. So where is that money going in our equation? Where is it? I heard it. It's going in place of f of n, right? So we're going to plug it in place. We're going to put 29 equals 2 times n plus 5. And look at us. We're right back to chapter 1 where we learned to solve an equation. How do we solve for n? Subtract 5. We have 24 equals 2n. How do we solve for n? Divide by 2. And so n equals 12 what? Because it's a word problem. 12 games. Remember, n represented the games. So n equals 12 games. And that is lesson 4.7.